cover summary 3. All right, so we just went through a really cool oil problem, converting barrels to gallons, looking at discrepancies between gallons consumed versus the amount that we might potentially make from the total U.S. oil production as well as U.S. oil imports. Now I want to take you to summary 3. Let's get up into the website a little bit. Summary 3 is a little bit different from the other 4 summaries. One of my main motivations for giving this summary was to give you some exposure to Microsoft Excel. It also gives you some modeling experience, so using different analytical math models for predicting the future based on current results, current trends. So let's get back down here in the summary 3. Oh, here's some notes. Okay, we'll get to that in a little bit. Yeah, that'll be very handy shortly. Gosh, and I guess did I not put the how-to on the summary here?
Did you already put it in the end? Because I think last semester we did summary 3 last, so it would have been like week 14 or something.
Oh, really? Let me just find it.
We may not have shuffled it back.
Oh, here we go. It's week 9. So let's look at the instructions. So I'm going to have you go out to a website called Worldometers, and I'm going to have you look at 2 separate statistics. One's going to be human population, the other one's going to be CO2 emissions for the whole planet. I'm going to have you put this into Microsoft Excel. I'm also going to have you do this 2 days later and a following 2 days. So you're going to get at least 3 data points for each data set, and that'll allow you to make a predictive curve. From there, you're going to do a linear, an exponential, and a parabolic curve fit. I think what you'll find once you've done one of them, it's just a matter of flipping a switch, and the other ones will happen without too much. And then, so you've done that for human population versus carbon emissions with a linear, parabolic, and an exponential model. And then I'll have you pick another variable of your own choosing. And so let's, and then...
Notice like people's eyes rolling back in their head. You don't really have to know what a parabolic or
No.
exponential curve
Yeah.
is.
No.
Excel does it for you,
Yeah.
so don't freak out about that.
Right. And I'll show you a couple examples so you'll know exactly what I mean when I say that. Okay, so let's go out to Worldometers. So almost 7.4 billion people on the planet.
That's just good enough.
Yeah, it is going up. I don't know why I keep getting these ads. One of my fraternity brothers invented this thing, and now he's spamming me with his ads. 12 million people born just this year. So by the time the year's up, half the U.S. population will have been added to the planet, believe it or not. A quarter of Montana has arrived on planet Earth today. This is how many people have died so far this year. Obviously, the birth rate is higher than the death rate. On average, about 3 people are born per second. That's about the average. 65 million people. So France has been added to planet Earth this year. About 65 million people in France. So an entire country of France is now less than a year old, here they are. And 135, so an entire Missoula County has also landed on planet Earth today, too. Kind of wild. So that's the first number you're going to track. The next one is CO2. So you'll see this number is approaching 30 billion tons of carbon dioxide emissions into the atmosphere. By the time we get to the end of the year, we're gonna hit close to 40 billion tons, and those numbers are very similar to what you see in your textbook. So what I'm going to ask you to do is to plot both the number of people born per unit time and the amount of CO2 per unit time on planet Earth. Now, just to do that, I'm going to start off right back in Excel with something super simple and show you more or less what I want you to do. I also want to take one quick look here. You do not have to express your time in seconds, as I said here. It gets a little cumbersome. It's probably better just to do it in days, maybe in hours, but probably better in days. If you do it in days and you look at the population, let's just say 2 o'clock on Thursday, then you do it again 2 o'clock on Saturday, then you do it again 2 o'clock on Monday. Then your units are in days, and you have to start slicing off into seconds. I know that says seconds in the spreadsheet. If you don't hit it, well, you could also use hours. You could also use fractions of days too. If you do it at 2 o'clock one day, and then you do it 6 hours later, 8 o'clock. That's sort of 2.5 days later, if you will. But here, let's just dig into the Excel. And we'll do the whole thing, start to finish. It's not that bad, and then I'll show you. And we've got time to, and we'll go over this again in class. It's not get it now or never. So what we're looking for is days in one column. So right now is day 0. 2 days from now is day 2. 4 days from now is day 4. And if we look at the population, I'm just going to put some small numbers in. Well, now let's put some big ones in. Let's go 7 billion, 7E9, and then let's go 7.1 billion, and then let's go 7.121 E9. So I just entered. I think I forgot my equal sign there. Maybe not. I think Microsoft knows that's a number. Okay, so that's our days in population. Now let's do CO2. Again, I'm just making these numbers up. You'll go in and enter your own. And we were right around what was that? 28 billion. Right now, we'll go 29 billion. Later, and then we'll go, let's just say 30.5 E9 billion later. Okay, now, this is really all the data you're going to take for this first part. So it's really as simple as that. And from there, I'm going to grab these cells, insert, and I'm going to go up to a chart, and pick this chart right here. It's the, I figured this was going to happen. Hang on. Let's do it this way. Pick this chart right here. Microsoft was smart enough to know, in this case, that days was the independent variable and population was the dependent. The way it did it before, it treated all 3 of them as dependent variables. So I'll just go with that. And so, in a sense, we're just about done. with the first part. Now what I want to do is, I know, well, shoot, I didn't get carbon on this thing, carbon dioxide on this thing, so bring it over here. I'm going to right-click, and I'm going to select data. I'm going to click on Add, and it's going to ask for a series name, so I'll click right there and tell it that I want CO2. It wants the X values, those are the dependent variables, and I'll click these three right there, and then it's going to want the Y values, and of course I'm looking for carbon, so I'll click those three right there. Okay, so now I've got my CO2 and my population both on the same curve. The issue is that the population's in the 7s of billions and the CO2 is in the 30s of billions, so I can right-click on this little guy here. I can right-click on the orange line, format data series, and tell it that I want that on a secondary axis. And that way it's just a little bit easier to read. Okay. And then you can come in, put your labels on and all that good stuff. Now, what I'm going to ask you to do now is just keep that chart as it is. And do this. I'm going to copy it. You can just copy the whole chart. Paste it. Now on the top one, I'm going to right-click on this and add a trend line. And let's just go with linear, because I asked for a linear, quadratic, and exponential. And linear, don't set an intercept, don't display an equation. Oh, do display the equation on the chart. We're going to use this equation to make a prediction. That's really the main point of this exercise. Okay, and then so from here, I'm also going to right-click on that and format the trend line label. Let Microsoft Excel know that I want that to be a number. I don't need that many decimal points, but I do need a couple more significant digits. There we go. So you probably recognize this as kind of a y equals mx plus b. You know, your just linear equation from algebra, that's what we're looking for. And I'm going to ask you to make a prediction. So here we are, October 15th. The course wraps up in December. I'm going to ask you to make a prediction in the future. What do I ask for here on the 60 days? Yeah. So all we're going to do right here is type in 60. We're going to make a prediction. And so from the population, really all I need to do is say this equals, it's y equals mx plus b. Now before we do that, let's just type over here what m is. And we'll type what b is. So in the case of the population, the slope is 52,500,000. And again, these are kind of made-up numbers, but that's it might actually be a little low. I mean, well, that's not per day. If we went back to worldometers, what's worldometers, people born today. Let's go back up to that.
Holy cow, how much money was spent on video games today?
Yeah.
Why is it even on?
So again, these numbers are a little bit artificial, but it doesn't. It's serving our purposes. So that's M, and then B is 6,998,333,333. Okay. So from here, all we need to do to make a prediction of the population, say this equals the slope, which is M, times x, which in this case x is just time. X is our independent variable, so times 60, plus the initial value, enter. Control 1, number. Now, one thing that you're not going to be able to do with this program, there might be some fancy way to actually grab the data that's in that field. For now, we just kind of had to copy it by hand over here, just kind of the way it goes. We couldn't very quickly change these numbers and expect something to update on us. But let's go ahead and just repeat the exercise for the carbon dioxide, add a trend line, display the equation. Fine, we'll take the equation, since it's the lower curve, we'll put it on the bottom. I'll do a right click, I'll format the trend line label, I'll tell it that I want a number with 0 decimal places, and go from there. Okay, so again, I'll just, I can take this, copy it here, paste it here, type in my M, which is 625,000,000, and this is 27916,666,667. And I'm going to get fancy. I'm going to drag this over. I know that it's wrong, but at least what it allows me to do is just take that, drag it back over, drag this back down here, and drag this back down here. So I don't have to retype the formula. I knew it was the same formula, but the values were just in a different spot in the spreadsheet. Okay, so now I've predicted what the population and the carbon dioxide emission is going to be 60 days from now. That's really the main point of the exercise, and we've done it with a linear model. So now all you have to do to make your predictions is come down to the bottom, you click on that, and it should be as simple as just dragging these two lines down for that curve. Come over here, drag these two boxes down, and there you go. So with this, and again, yours is going to look a little bit different, but what we've seen is that from this model, if these are the numbers, the CO2 emissions per person has gone up. And that's sort of, that's important, in a lot of ways, because, when global economists are looking at quality of life, quality of health in general, societies that use more energy are wealthier. There have been some downward trends. The Shramsky paper that you'll read in 102 shows that actually the energy per capita on planet Earth is starting to diminish. And that's going to happen because of one of two things. Either greater efficiency, people drive less, eat better, more efficient lighting, what have you, or there's actual poverty, meaning that people do not have sufficient access to electricity, can't keep their food cold, refrigeration, et cetera, et cetera. We hope that the former is true. We hope that we're sort of becoming more efficient as a civilization and less impoverished. But you can see that as the population grows, how do you balance those things? How do you have more people and actually less poverty? It's a challenge. The Pope's actually addressed it. I don't know. I think the Pope just said that throwing food in the garbage is a sin. And maybe, if in fact enough Catholics stop sinning by throwing their food in the garbage, maybe some of the impoverished and hungry folks around the world will get, I don't know. It's nothing I'm going to solve sitting here, but maybe the Pope's working on it. Okay, so that's really the exercise. From here, guys, it's pretty simple to complete the other two portions. You're going to want to just take this this little graph right here, copy it, stick it over here, paste it, stick it over here again, paste it. Now on the trend lines, format trend line, this is just going to become your polynomial. You can see the equation is different. Display the equation, fine. We'll do the same thing down here. Polynomial, updated equation, boom. So once you've kind of got your figure where you want it, the rest kind of does itself with the beauty of copy and paste. I can come over here, format trend line, exponential. That e to the 0x is a problem. Let's see if I can't fix that. Okay, that number's tiny, you're not going to be able to see it on the screen, but I had to extend the number of decimal places so I could actually get the time constant, if you will. So with the polynomial, you're going to have 3 coefficients. With the exponential, you'll have 2, but you'll just type it in the same way that you did with your linear. And then you'll do the same thing down here. So we'll take that guy, copy it, paste it. Well, these bottom 2 are not going to make, they're not going to make sense yet until you come in, and what you're going to want to do is just on this side, call it linear. And you can more or less take this whole thing, copy it, stick it right down here, paste it, and I'll leave this thing as an exercise for you to type in your quadratic equations, but you're going to get those numbers from these charts for quadratic. Copy it one more time. Paste it, and this is exponential. And again, you'll put in your 2 equations right here. Here's where you'll do your calculations. So I'll make those green. Okay, well, I realize I went through that kind of fast, but any kind of questions in general? At the end of the day, you'll have a let me go back and click on that. Click on that little example that I showed. So you'll end up with, so these 3, this is population and CO2, linear, quadratic, exponential. And the graph you're going to show are the graphs you're going to give are your predicted models, the ones that go out to 60 days. So your time 0, 2, and 4 are kind of bunched up here at the beginning, and you'll see 60 out there. You do it linear, quadratic, you do exponential. Those are the 3 graphs, and then you do it again for your favorite variable. Somebody mentioned TVs, so if you want to know how many TVs were made or how many dollars were spent on video games, you more or less same thing. Okay, so that's summary 3. Tim's going to run through the rest of chapter 7 for you next week, because I'll be out of town, but I think that'll do her. Okay, thanks. Yeah.